Hi, everybody. This is Jeremy Howard from Fast.ai, and I'm here with Johno.
Hey everyone.
Johno is going to be demonstrating some really cool stuff later today, so look out for that. But maybe before we get started, I should tell you a bit about who we are very briefly and hopefully convince you that we are worth listening to. So we're going to be talking about how to solve it with code, and this is the first lesson. So if you haven't heard of Fast.ai, we are the world's longest running deep learning and AI education provider, and are also an R&D lab. Over the last, gosh, I don't know how many years, nearly a decade now, lots and lots of people, alumni of Fast.ai, have gone on to big things. I asked Grok before we started to jot down anything it found, and it's listed a few examples of people who, as far as I know, every major research lab in the world now has alumni from Fast.ai there. Some interesting examples. Suhail. Wait, you used to work for Suhail, Johno.
Yeah, I joined them.
He's the CEO of Playground AI alumni. Got a nice message from somebody saying he just got a job as an applied researcher, saying he just a high school grad, no college, not just Fast.ai. Vice president at one of the world's top pharma companies of AI, says all of our folks go through Fast.ai. Christine McClavey, who's, I think she leads voice and stuff at OpenAI, is another great alumni. She's amazing. John Wu recently just became a tenure track professor and has documented his background in Fast.ai. Lots of folks, so if you are part of this community, you are amongst good company. With our students, we've done some really cool things together. We broke some world records in creating the world's fastest model training systems. And as well as our teaching, our research has also been really significant. Most famously, this is a family tree of LLMs. This one here called ULM Fit, which goes there, was created by me. Actually during a course. And as you'll see, it is the very last one before the explosion. And that's because ULM Fit was actually the world's first modern LLM, as popularly understood, using this three-stage process of pre-training a language model, fine-tuning a language model, and then doing a classification type process at the end. So all of this is to say, hopefully we are worth listening to. We will do our best to say things that are useful. We're not going to try too hard to convince you that you should be. So we're going to be trying to help you improve at your craft, where that craft is generally doing things with code or about code. But we're also going to cover quite a bit of stuff about writing prose, about reading, about learning. And at no stage really are we going to say, okay, in order to do this, just ask an AI to do it for you and come back half an hour later. Some of the things that we're going to practice, you could ask an AI to do for you, and you could come back later. But it's becoming quite clear that outsourcing too much to AI is causing a lot of problems for people's careers, for organizations, for people's mental health. I'm not going to try to convince you, but if you're interested in learning about why you shouldn't just join a course that says how to outsource everything in your life to AI, you might want to watch some of these videos, such as Andre Karpathy, Chris Latner, or even me. So as Andre said, when you build something from scratch, you're forced to come to terms with what you don't understand, and you don't know that you don't understand it. It always leads to a deeper understanding. It's the only way to build it. So if you're literally outsourcing, try to outsource all of your building to AI, you're never going to get the deeper understanding. And so you're basically going to crater in terms of your competence and also your confidence, because you won't have that experience of doing something yourself. We're going to show you how to do stuff on our platform called Solveit. We created Solveit specifically for human agent works. So for stuff where you are driving the process and it's designed so that you're learning as you go more about what it is you're building and how to build it and learning skills and improving at your craft. Sadly, nobody else seems to have tried to build something with that focus, and therefore there's nothing else in the world right now which is as good for the Solveit method compared to this platform. But you don't have to use it to use the Solveit method. It'll just be a little less convenient. So I would say though, like, don't stress too much about like how to bring your problems into Solveit and bring the solutions back into your native environment. You know, if you're doing a bit of copying and pasting or whatever, it's okay. You know, you don't have to have perfect efficiency in which your computer does everything all the time. We'll be showing you how to automate stuff a lot more in terms of that stuff, but a lot of people coming into Solveit are very focused on like, this isn't the exact same environment I use at work. So how can I use it? I can't use it because it has to be exactly what we have at work. So don't worry about that too much for now.
There's also going to be this piece of the thing that's actually showing on the screen is going to be the interface and the code that Jeremy's typing. But the most important of the two pieces is more the method and the thinking and the approach. And so one role I'm going to play is if you've got questions in the chat or if I've got questions like, why did you do it that way? What did you break that up? Those are the ones we really want you to take away. And the kind of like which buttons to click minutiae are secondary to that overall like approach that we're going to be showing.
And when we say we're going to show you how to solve problems, that includes problems like, how do I write this article? How do I read and understand this paper? How do I add this feature to some software? How do I spin up a Linux server? Like, we're using it in a very general sense. And interestingly, you can actually reorient all of these questions as being, I want to learn to do something. I want to learn how to write this article. I want to learn how to read this paper. You know, at some point, the definition of where is learning finish and doing start really starts to get gray. And as I'm sure Johno's very much noticed in my life, that's particularly true. Pretty much everything I do, I tackle with a learning mindset. And I think you do as well, wouldn't you say, Johno, on the whole?
Definitely. And it's a lot more fun that way.
Okay, but here's kind of one interesting way of thinking about it. How do you leverage Solveit? You know, if even if it's not integrated into your workplace's, you know, enterprise platform, and it takes a moment to copy something in and set up some test data and takes a moment to take the result and put it back. None of that's going to be useful if you don't have problems worth solving, by which I mean a lot of people tell me, Jeremy, what's the point? I don't need Solveit because like I just create boilerplate. You know, like I code, but it's just boilerplate. And people are like, well, why don't you use agents? Because agents can write all the boilerplate. Like, okay, you have a problem to solve. Your problem to solve is you have too much boilerplate. Like, you should be able to, if you're coding, you should be able to read your code clearly, briefly, and see exactly what's going on. So, like, let me give you an example. I tend to try to do things that are like very current. So, for example, I mentioned John Woo earlier. That's because he got his tenure track professorship 2 days ago. You know, so everything I'm doing, I tend to be very current. So 2 days ago also, well, last week we added a new feature to Solveit, which is kind of Git integration and versioning. And you know, before we deployed it, we realized like, oh wait, we've got a problem, which is that we actually need our Git program to run under a different username to what the web app's running at. Oh, the Git Python library doesn't support that. What are we going to do? So one approach would be like, lots of boilerplate, right? Sudo -u solveit git hundreds of times, you know? And I was like, okay, no, we're going to delete Git Python entirely. We're going to remove the library we were using. And I replaced it with a single function. So this is actual code from Solveit I'm showing you here. And so as you can see, we're writing Solveit in Solveit here. And you can see I haven't changed this from, I can't remember, it might have been Tommy who wrote this, from how it was first written, which is, you know, we have these inline documentation. This is how we write stuff in our workplace. And I wrote a little thing when I modified Tommy's code to add call git. And it's very simple, just calls subprocess.run, and it's running sudo and some arguments. And also git -c, which means it basically it runs it in some particular folder or path. I was like, cool. So now, for example, in order to find out if we're inside a Git repo, what's the top level of that Git repo, we can say call Git with the folder we're in, rev pass show top level. That's how you do it in Git. And cool, that was going. That was starting to look good. And I was like, there's still quite a lot of boilerplate in all this call Git folder bizzo. So after I was doing that for a while, I added this little class called Git, where I can now create a Git object. I can pass in the directory, and I can do things like a property called exists, which checks whether top, which just that top level thing, is none. And I added a call to it. Don't worry if you don't know all this somewhat Python specialist syntax, but this allows me to treat it exactly like like there's a method called revpass. So now rather than having to call git revpass, I can just go self.revpass. And rather than calling git init, I can now just say g.init. So you can see, and again, this is our real code, right? So you can see in our code base, we immediately add a test, just to make sure everything's working and also to show the reader how to use it. And we're not creating thousands of lines of code. I've created, what is this, about 20 lines of code, if you exclude the tests. And it worked. It took, I don't know, an hour, half an hour. And the other thing to mention is I did all of this, as I do most of my work, with a friend. So I did this with my friend named Curtis, who works with me. And you might be like, wow, 2 people, what a waste of time. We can't afford 2 people. But we're not trying to make every minute as efficient as possible. By doing it this way, I remember, for example, Curtis noticed something that, in hindsight, I guess it was pretty obvious, which I was always trying to use this top thing to find where the top level was and then CD to it to make sure I was in the correct directory. And Curtis reminded me, like, no, Jeremy, you don't have to do that. Git always knows which repo it's in. And I was like, oh, that's right. So, a lot of the ways in which we work at Answer AI is super different to most companies. But also, if you go and have a look at our webpage, we have 9 people in total. That's it. We don't have marketing staff and advertising staff and PR staff and finance, like whatever. We're 9 people, including me, and I think we're pretty efficient. And then after that, later on, I noticed that I kept on saying get.log, get the last one in a particular format. So it's like, oh, that's how I get my last commit. So I added a property later on called last commit. And then I can just go, okay, git init, assert, git ignore in last commit. Print g.branch. And then, later on, we start adding some tests, more tests, which is kind of like a documentation to take the reader and the computer through the whole process. Yeah, so what do you think, John? It's a bit different to, I guess, other ways that companies tend to work, right?
It is, and it requires some very careful reframing and training, and I keep having to remind myself of these pieces, because you showed an example there where, okay, so first of all, there was a library that did mostly what we want, right? And then there was a version that you wrote that worked, it was technically fine. And so there's this short-term calculation where you say, okay, it's going to take me, some hours to rewrite this. And is it really going to save time? It's probably going to save me a few keystrokes here and there. And so the very short-term version is to say it's a waste of time, right? To do the second version where you were digging a bit deeper, using some of the Python internals and messing around with Curtis. It's like 2 people wasting 2 hours, wasting. And that's if you frame it that way and you're focusing on the deliverable by the end of the day, it's one inefficient way to work. But the next day when you want to add some additional features with Git and it's just a pleasure to use and a joy and it's a little tiny bit of code, and then the next month when you have to come back to it and you go oh, I remember I made this nice Git thing, I can do that. That compounding interest of that initial extra 2 hours or 4 hours of dev at the start means that months later you're still reaping, oh, it's such a joy to come fiddle with the way we do Git because we spent that time to do that 3rd rewrite or that 4th rewrite or that minor refactor that made things a little cleaner to work with.
Even if not, even if it was only 1-to-1 or even half,
Mhm.
It's like, well, I've learned something new. I've done some deliberate practice. I've had a nice time. I've done a cool project with my friend Curtis. Like, this all has a lot of value. And actually, the thing I care most about in our staff is that they are continually developing their craft. Because if if Johno never learnt anything new for the next 5 years, that'd be so sad for him, for me, for the company. That's definitely not what's happening, right? So, yeah. Okay. So, shall we dive in to some examples?
Yeah, let's start showing the approach in action. And
Okay.
to maybe frame the background for everybody, the way we're going to try and run this course is to illustrate these examples. And the one I just gave of saying, oh, like in a month's time, this is where we'll start to see the sort of appreciation and the enjoyment. Obviously, we have to fit all these examples into an hour or two of a lesson. And so some of the pieces are going to be very small. The problem Jeremy's about to start on is going to be a very small problem. But hopefully the preamble that we've just given and some of the later showcases and examples we'll show will convince you that this works up and down the hierarchy. This is not just a 15-minute problem approach. This is what we generally use for everything that we do.
I think I'm going to start with, I wasn't quite sure I was going to start, but having thought about it, I think I'm going to start with a simple problem solving exercise. And so just like primary school children, can use calculators to do times tables, we encourage them to learn them and practice. So same for something like learning to solve basic problems with code. I think it's a great idea, and I enjoy doing it. And Advent of Code's a nice place. These numbers, as they go up, they get harder and harder. So you can, generally, most people, I would have thought, watching this will be able to handle day one, or at least the start of day one. And if you find that a challenge, no worries. You can go back to previous years, 2023, 2022, do day one. If it's so easy that it's pointless, go to try day 20. As I show you, though, you can actually learn a lot, even from day one. So I'm going to do this in Solveit. So when you go to the dashboard, you'll see that you can just hit the connect button, and that will pop you into Solveit. And from there, you can create a dialogue. So what's a dialogue? A dialogue is a conversation between you, the computer, and an AI. Sometimes it'll only involve the computer, i.e. code. Sometimes it'll only involve the AI. I find for most of the time, it's got both. So we'll say Advent of Code. This is number 1 of 2024. Create. And so when we create a dialogue, you'll basically see we end up here with something that looks a lot like ChatGPT. And indeed, if I hit the prompt button, everything's got keyboard shortcuts. So this is Command-Shift-L on a Mac or Control-Shift-L on PC. So we're pretty lazy here. We used C to mean both. So I can say like, hi there, I would like to try doing an Advent of Code problem. And very minor thing, I think it's a great idea to have a high quality voice interface available, particularly when you're chatting to an AI. It's just so much less overhead to type. Here I'm using Mac Whisper, which I like a lot. You can see it's sitting up here in my menu bar. The default one that comes with the Mac is terrible. The default one that comes with Windows is not too bad. Johno, you've probably used the Windows one more than me recently. Do you think it's all right? Or have you used it much?
I've just been dogfooding Mac, but the Windows one, I think it's the Windows key and the H to start recording. Yeah, it's solid for just inputting a piece of text without having to move these meaty sausages around.
So as you can see, I can ask it for help. And what I'm going to do is I'm just going to go ahead and copy the Advent of Code problem I'm going to solve in. Generally speaking, LLMs quite like Markdown. So to convert stuff to Markdown, one easy way is to use something called r.johno.ai. Anything I do more than a couple of times, I like to automate. So I've added a button up here in my toolbar, which Solveit can help you create this if you want to. It just goes JavaScript, location, href is Johno AI. So I'll hit that button. And now it's Markdown. So I'll grab all that. And so as well as a prompt, you can also create a note, which is just a bunch of Markdown. Now you'll see that when you start typing, the thing you type into is very small, and it's kind of trying to gently encourage you not to do too much at once. But as soon as you start typing more, it'll grow automatically. If you want it even bigger, you can hit Command-Shift-X or click this button to use up nearly the whole thing. So that all looks
for
pretty
anyone
good.
watching who's a little confused by references to elves and chief historians and so on, the advent of code is it's a delightful series of programming puzzles, often written around a theme. They come out once a day during December, so the new ones will be starting in a month, and we'll get to try them out. And so that's the context here, is we have this kind of little Christmas themed or fairy themed story about elves and lists, but at the end of the day, there's going to be a puzzle hidden within there where we need to somehow figure out an answer and submit it to help the elves out on their journey.
Thank you, Johno. There's a lot of little tricks. This is Solveit's quite a sophisticated system. You don't have to know any of them, but for example, one thing I like to do is turn this into a little scrolling area rather than take up heaps of room. So that's Shift-I for input. You can change the scrolling area of the output with Shift-O. And we can see here our problem. We'll read it in a moment, but I just want to point something out to you. I can say, this is the problem that I would like to solve. I am fairly new to Python, but I know the basic idea of programming. So normally an LLM would just go and give you pages and pages to tell you exactly how to answer it. But Solveit's very much designed to not do that, as you see. So it encouraged me earlier on to tell it about my background, and now I've done so, and it's telling me, giving me some basic directions to get started. The problem here says that let's not worry too much about the elves and the chief historian. But basically what we need to do is we've got two lists, and we need to see if we can see how, I think, similar they are. They need to reconcile their lists. So here's an example of a list. So it says pair up the numbers and measure how far apart they are. Pair up the smallest on the left list, so that'd be 1, with the smallest in the right list, so that would be 3. So this is what I always do first to solve a problem, is I do it in my head, properly. The advent of code is very good at giving this practice of always having a small example problem, working fully through the example problem, and only then going on to the big problem. I find most people, as soon as they leave advent of code, forget all that, and as soon as they have a big problem, they start to try tackling the big problem straight away. They're like, oh, we have 14 terabytes of data. Oh, step 1, how do I load 14 terabytes of data into my table? It's like, no, start with 10 rows. And then once you've got 10 rows, start with 1 row. We're going to be doing a bit of stuff with advent of code, so it's a good idea to learn to be efficient with it. There is a thing called advent of code data, which is pre-installed in your environment. And I won't show you, don't worry about this pip install, it's already installed, but you are going to need this key that you can copy once you've logged in to advent of code, which you can do by logging in. And it says here, say export, and then put the key. Now you actually don't need to do that. All you need to do is grab that text advent of code session, AOC session, and over here create a secret and paste in your code here following the directions. And you'll see I've actually already got mine. So having done so, it will end up just as if I typed that export thing, but it'll be there all the time, which is very handy. And so, yeah, there's a bit of information here about how to use it. So maybe we'll just start by copying. Nothing wrong with copying. So we're going to have 2024. day one. Yeah. So, even learning how to use the advent of code data, we can start to learn some things about how to work in this kind of environment. So Python is nearly uniquely good as a modern programming language at its ability to work in this kind of dynamic environment. So you can do just about everything. So for example, you can type __dict on anything to find out all of the stuff it contains, for instance. Or you can type dot and immediately see all the things you can do. And you'll notice none of this requires any typing or hints or anything like this. This is much more accurate and correct than any kind of annotations or type hints or anything like that, because it's actually looking inside the interpreter and asking it, hey, what can you do? And so I can see here, one of the things it can do is examples. And so this is what I do. I start to play, right? And so I can see it's a list with one example in. So that means I can get, so I often do a lot of this, just going back and gradually adding more stuff. It's like, oh, there's my example. Cool. So then I'd probably give this a name. And then you can just pop the symbol afterwards and both define it and see it. And great, so we've got some input data. So I'd put that into here. Input data. And so you can see everything popping up automatically. These are always perfectly correct for the reasons I just mentioned. So the way I'm submitting, I'm doing everything with the keyboard. So submit, you can see is Command or Control Enter. But actually, there's a number of ways you can do this. I tend to use Alt or Option Enter. So if I do that right now, you'll see not only did it submit it, but it created another one underneath and popped the focus down here. So this is how I can just add lots of code or prompts in a row. So that's key, that Alt or Option Enter. Great. So if I wanted to switch over to it being a prompt, I can now say like, okay, I think I've got basically everything set up now. Does that look right? And also, if you want it to spend a bit more time thinking before it answers, you can just hit the Use Thinking button, which is Command-Shift-D. And if you do that, you'll see it just takes a little longer. Well, it has to think first. So it's showing me, what should you try and do? And so, how you go from here, if you don't already know how to split each line, is you could go to the Python docs. You can just ask it, tell me how do I split each line, or maybe you know. So I know. So I'm just going to go lines equals input dot split lines, or you can just start typing, and
Also, Jeremy, I wanted to ask, it's one thing to say, okay, how do I know whether I should split these lines into pieces? But more generally, like how have you even got to the stage where you were looking at this problem, now you wanting to split the lines? Is there a point at which you're looking at the whole thing, or is this still the like, oh, I'd like to dive in and just poke at the data and get it to the point where I have everything loaded and then I'll make a formal plan? What's the like thought process when you're choosing even like what is the first piece of code to run?
I don't tend to plan a lot. I tend to just think about what's a single step I could do that could get this into a slightly better shape than it is now. So, currently the input data, it's a string. And it's like, can't do much with that. So a list of lines would be a little bit better. So that's kind of my thinking, is just be like, okay, let's make it a little bit better. And if you haven't used split lines before or not for a while and you can't remember what it takes, you can just hit Shift Tab inside the parentheses and it'll tell you that it's got a parameter called keep ends. Breaking at line boundaries, line breaks are not included unless keep ends is given. That sounds pretty good. So I'm just like, that sounds a bit better. So I'm just going to like go ahead and type in there. That's a bit more convenient than it was before. And then I'm like, well, better still would be if each of these was split themselves, So I might be like, okay, split lines equals And, well, or we could just do it, possibly. Like, so now I'm starting to think about, my head's just thinking like, what could I do? So I need to actually add up the difference between the sorted versions of the two lists, basically, to find the smallest in each, the second smallest. I need to sort them. So yeah, I do need them to be in two lists, actually, right? So, so here's where, if you're fairly new to Python, you might start typing, x's equals here, and then start typing a for loop, and so forth. And this is where I'd be like, can you learn something new today? So I could be like, okay, I know how I could create the two lists using a for loop and creating an empty list first, but I'm wondering, is there some more concise way to do this? I'd like to try to learn some new Python tricks today. So I just let it know that you're looking to learn new things, and Solveit's generally going to encourage you to try to learn things anyway. So this is exactly what I had in mind. So that's great. So I'm not going to show you this Python right now. And the thing is, that's a nice thing about teaching in this environment. I don't have to teach you everything because, um, in this environment, you can just ask, right? And you don't have to be embarrassed about asking. You never have to be embarrassed about asking, but particularly when you ask a computer. The computer's not going to judge you, I promise. So I'm going to say line.split. And nice little trick, if you didn't know it, in Python is that split actually, by default, when set to the default, it will split on any white space, which is exactly what we want. So x's, comma, y's. There it is, right? And so now I'm basically ready, I think, to solve it. I just need to sort these. So they're currently not integers. So we'd want those to be integers. Then I can sort them.
There's another piece here, Jeremy, that you did implicitly, and I'm just going to call it out for those watching. You didn't just write the line of code that created those two lists. You then printed them out, right? Just by typing the names of the symbols so that you can see them there. And then you looked at that and you said, yeah, that looks right. In other words, you've seen what the original list is. And then if you look at the first one in each, it's like, okay, the first one in the first line was a 3, the first one in the second line was a 4, then a 2, and then a 1, and then a 9, or sorry, then a 3. And then you can see, okay, that's exactly what we wanted, and that's exactly what we got. And at every stage we're doing this. It's not just like, oh, I know the code to do this, I'm going to type it out. It's like, I know the code to do this, I'm going to type it out, and then I'm going to inspect the output to say, am I proceeding on my track, right? Like, it's not just theoretically, I would hope that this would put it in a nicer formulation. It's that, no, I can see straight away. I can see the output and check, yes, I have in fact moved a step towards where I'm wanting to go.
Thanks, Johno. Yeah, and maybe then you might be like, okay, I'd be interested in learning some more Fast.ai tricks, like FastCore has a neat little thing called L, and so then you might be like, oh, I could just grab those and I could make each with one of those an int, for example, and wonder if, and then I could possibly sort that. Wonder if that would work. So it could be like, have a look at xi's. Xi's dot. So this is where I kind of tend to type. Oh, interesting. I could have a sorted. Oh, that's nice. Cool. So then I'd be like, okay. So often I'll kind of like play around on the next message to kind of get a feel for what I want, and then kind of go back and it's fine to have little bits of duplicate code. I don't have to have everything perfectly factored away. I can just copy and paste that. And so then I can have a look and say my xi's and my yi's, and that's all looking pretty good. So then I just kind of say like, okay, I think I'm done. So I can now say res equals 0 for x comma, well, there's a few ways to do this. And again, I'll try and show you something a bit new. If you don't already know, this is a nice little trick, is to use zip xi's comma yi's. Otherwise, you could do for I in range length xi's, index into it.
You probably want for x, y in zip. X size, y. Right.
This is why you want pair programmers. Res plus equals absolute value of x minus y. And then hopefully that should be 11. So I tend to think what it should be before I run it. Otherwise, you can kind of convince yourself. And this is where, all right, now I want to run this on the whole input. So in Advent of Code, they give you the examples. And then they also say, all right, now run it on the whole input, right? And the further you get, the more running it on the whole input without running out of time for the rest of the universe's lifespan, it gets harder and harder. So there's a few ways to do this. And so this is where we've designed the system to make this convenient. So one thing I'm going to do here is I want to split this import out. So I'm going to press Control-Shift-Hyphen to split it into two cells. And I can basically see I need to, start here and then gradually, do all the stuff. I'm going to put it into a single function. So there's a button here called copy. Sorry, that's the wrong one. I need my copy. Is there a button for it? Or maybe it's just the keyboard shortcut. I don't know the keyboard shortcuts because I use them so much. So comma copies the input and full stop copies the output. Normally our input-output versions are next to each other on the keyboard. And as soon as I hit copy, you'll see I just hit comma. Do you see how this is now flashing down here? So it immediately gets me ready to paste. So I can paste, right? And then I can scroll down a bit. What else do I want? Yeah, I want this one as well. So I'm going to hit comma again. So hit comma and then paste. And yeah, I also want, I think actually this button's wrong. I think this is the comma one. I'm just going to try it. Copy. Yeah, it is. That's actually not C. That's the comma one. That's good. Oh, yeah, this is the last stage. Copy. And so you see how it made it really easy for me specifically to take bits of stuff I've built gradually and combine it into a single thing. So these are all the little things we're trying to do to help you use the Solveit method, which is all about small steps, seeing what you're doing as you go. So I'm going to create a function here called calculate 1A, because this is part A of day one, and I'm going to give it some input. And so then we can hit Alt right square bracket, and then we can check that calc 1A.
I'm giggling because I've seen a bug for you watching. See if you can spot it.
On my input. Now I'm curious. I didn't return anything. So I can see by doing it straight away. So this is a nice thing about this approach is I'm terrible at coding. I make mistakes all the time, but my mistakes are either in 4 or less lines of code or in just combining bits of code I already wrote. So, generally speaking, it is within my capability to manage debugging that.
So there's a great question in the chat, Jeremy, which is someone asking, like, do you now go and clean up this whole notebook? Is there a phase where you're going to delete all the experimentation and keep this? I think they asked it before you started building this function, but yeah, what is your thoughts on like copying and pasting those lines from earlier down here versus trying to like maybe combine all the earlier ones and erase the process?
Yeah, it's a great question. Let's just see if I get the right answer, shall I? Calc 1A. My 1's not working, so I'll switch to the other keyboard. So I think I should be able to now go to my puzzle, and there should be a input data. There we go. And maybe before we use that, just hit escape. And I just want to add something above this. So it's A to add above. And I just want to have a quick look to see what that looks like. Okay, so that's it. Yeah, that looks good. It's just a string. So that's what I was hoping for. So I just hit X to delete that. And then I press full stop to copy the output. And everybody gets different puzzle data. So you won't have the same answer as me. And I don't know if this is correct. So fingers crossed. It is. Okay, and after you've done that, it'll give you part B, part 2. So, we tackle this question a lot within Answer AI, and there's no one single answer. Generally speaking, if something was difficult enough that you needed to spend a little bit of time exploring it, which is like anything that's not totally trivial, then probably you in 6 months or your colleagues would feel the same way. And so when they then come to add a feature to this or debug it, when something changes in the future, it would be much easier for them to work through the line by line, explanation, than to kind of dive straight into the big long code. So we normally keep it around, and we'll dive into this later in the course, but you can read lots of our code. Our source code is all actually, everything we write pretty much is all written in Solveit or in notebooks. And if you look at the Claude, for example, Claudette, which is a library I created as an Anthropic API wrapper, basically, you can see me, first of all, I'd never used it before. So the first line of code I wrote was to create the object. And then I created a message. And then I tried sending it. And I looked at the thing I got back, and then I was like, oh, it looks ugly. So I created a little thing to try to make it look a bit prettier. To do that, I needed a few steps, and I printed them as I go. So, and so then when my colleagues later on came and added more features, I didn't have to tell them how my code worked. I just said, okay, colleague, here's the notebook. And you just dive in. So I think that's but you can go too far if it's something that's trivial and you really didn't need all that detail. You can delete it. Do you think that answers the question okay, Johno? I know it's a bit of a subtle.
I think so, yeah.
situation.
You'll see as the course progresses, as we build up our own notebooks, some of which are going to be single-use exploring, some of which are going to be building pieces that we'll use later. You'll kind of see in practice the mix of little bits of tidying versus keeping the whole artifact. So it's definitely not like a one-size-fits-all, but I think in general, especially because it's so easy to share or to keep a version that has everything, it's really nice to have those steps for later. And so you should probably err on the side of, let me just make another copy and tweak it rather than I should only ever have one perfect function at the end of the day.
So I said, even if you're good at Python and data structures and algorithms, this would have been trivial, but you can have fun with stuff like this. So maybe okay, I think I'd like to learn something else new. I've heard about this thing called NumPy. Would that be something I could make this more concise? I'm keen to see how concise I can make this. And I know it's already fast to run, but I'm kind of wondering whether there's some theoretically better performance or something. Got any ideas? And for something like this where I'm kind of asking for it to be a bit more thoughtful, I'll often hit the use thinking button. Because, I don't mind if it takes an extra 10 seconds. So that sounds great, right? So just to give you a sense, I'm going to have a try. So I go from NumPy, import array. Maybe I'll also import sort. Import NumPy as MP. I'm just going to have a little bit of fun here. So what I tend to do for this kind of thing is I often build it up on one line slowly, as long as the line ends up feeling reasonably readable. And I tend to assume the person reading it is competent. And competent doesn't necessarily mean they know all the libraries I'm using, but it does mean they know how to look it up. And since they'll be working in a notebook or Solveit, I know they can experiment with it right there. So I can have quite high expectations of my colleagues. Also, because they're people like Johno who are super smart and tenacious, that helps as well. So I would start with my lines. In fact, we start with our input. Okay, so so we did that thing where we went, O.split for O in lines. And, here's a, let's do it right from the start, input.split lines. And this is one of these things where it's people might be like, oh, you can't call it O. What if you forget what it means? Like here, like literally, O is being used only on this line. It disappears as soon as I finish this line. This, this is a good place to use small symbols. Cool. How do I convert that into an array? Well, actually, you can just do it. So you see how I'm like, oh, I didn't run that.
Triple R is the problem.
That doesn't help. Array.
It's the pirate's
Stop using
library.
this keyboard. Okay, so again, it doesn't matter if you know about NumPy and you know about arrays. I'm just showing you the idea. And so I'm not hitting Alt Enter now. I'm hitting Shift Enter or Command Enter. And then I'm immediately just hitting Enter on my keyboard to jump back into edit mode and just gradually building it up. It's like, oh, I want those to be ints actually. Okay, great. So now, this is a columnar matrix, if you like, or two columnar matrices. I want there actually to be two rows so I can split it up easily. So I use something called a transpose. And it's like, oh, there we go. Great. So that's my X's and my Y's. So it's comma Y's. There we go. So those both need to be sorted. I need to take the absolute values of the differences. So I could say sort X's minus sort Y's dot, oh, that's all one thing. Take the absolute value of all that and then add that up. Okay, now that was fun, right? And then we can double check that we end up with the same thing. So since there's only two of them, I'm just going to hit C, and then I'm going to hit V, and then I'm going to hit Shift M to merge them. And I'm going to delete this. And so this is my def calc 1A using NumPy with an input. And before Johno starts laughing at me, I'm going to type return. And then we'll see calc 1A NP input. And then we'll say calc 1A import NP on my puzzle.input data. I remember what it was called. That's the same number,
Nice.
So that's it, right? It's like I'm just saying, people are often like, oh, what if I'm just doing something and there's nothing to learn? So I just like, it's like, well, why are you doing something where there's nothing to learn? Like, surely you should have automated it if there's nothing to learn. You know exactly what you're doing. So then learn to automate it, or learn to do it faster, or learn to, like you're literally spending time doing a thing. Why? Anywho, that's that. I'm going to just quickly show you 5 minutes, one more example before I jump over, maybe 10, before I jump over to Johno. Anything to add before I move on, Johno?
No, this is a good example. Like the reason we're doing this course and the reason we're doing Advent of Code is not because those solutions themselves are useful to us. It's because it's fun to learn, right? And so we'll show some examples that are more useful. I think the one you're going to show now is maybe something that people might use, in their day-to-day. But the attitude we want to engender in everybody is to get to the end of solving something and then go, I wonder if I can solve that using NumPy instead, right? To have that kind of curiosity mindset. That's like number one prize for outcome of this course.
All right. So thank you. So this is a problem I recently had to solve, which was I did a really, really interesting chat with Chris Latner, who's an old friend of mine, who I think is one of the greatest computer scientists and software engineers of our generation, and one of the most significant, anybody who's both created LLVM, which is basically at the heart of every piece of software we use today, and also created a whole programming language everyone uses called Swift, and a C++ compiler called Clang, and he's now the CEO of Modular. He's created a new language called Mojo, and he created the platform that just about everybody uses for AI now called MLAI, and blah, blah, blah. So, okay, if you want to know what it's like to be good at your craft, Chris is good at his craft, and he can teach us. So I wanted to take my conversation with him and turn it into a written version that respected the value of what he had given me, so I wanted it to be really good. And so is this good? Well, 2 days ago, you guys all know O'Reilly, right? The most famous technical book company in the world. It's named after a guy called Tim O'Reilly. Guess who emailed me? Tim O'Reilly emailed me himself direct and said, Jeremy, this is an amazing article. I really want O'Reilly to publish this, please. So I think it's a good piece of writing as judged by somebody who understands technical writing perhaps better than anybody else in the world. And I created this in Solveit. And I started out with a transcript of my chat with Chris. And this is a very interesting starting point, right? So if you go into AI and say, like, please write a powerful and compelling description of the power of software craftsmanship and how to do it in the age of AI, you'll get garbage, But if you start with an interview, it's more of what I would describe as a style transfer problem, which is to take words that are already there and convert them into a slightly different format. And AI is very good at that. But I still actually didn't have AI write my words. So let me show you how I went about this. I started just by telling it I'd like to write an article. And I found this interesting. Like, it's all about creating software that lasts. So I said, like, show me, remind me, basically, what are some quotes, right? And then I was like, yeah, this is good. Yep, I want that to be the main theme. Okay. But there are other themes. So again, this is something AI is good at, just like list themes, list quotes, right? So there's no chance of AI slop here, right? These are our words, it's copying them. And there's no chance of worrying about hallucinations because I was there in the interview. I remember if I said it, and it's very easy to check, right? So I was like, okay, those first two are kind of about the main theme I described. It's like, okay, how do we get through those other themes? So I asked her ideas about narrative paths. And I quite like the two paths it suggested. And then, Johno, you'll remember, I actually jumped onto our internal Discord and I said, guys, which one? Or, what do you think? And so we agreed on a particular approach, which was more path 2 oriented. And this is really nice. It's kind of done this work for me of like, my brain's not big enough to keep all these ideas in my head. So it's really helpful for me the way it kind of put these into pieces. So it's like, okay, we chatted, we're going to go this way. Here's why. But maybe I should start like why I decided to talk to Chris. So if you have a look here, I've like the background, right? Why? Because like literally, why do they call Chris? It's like, because I was upset, nervous, worried, wanted to know what to do about it, see if he had the same feelings. Okay, so again, give me some quotes. And then I just started writing, right? So I wrote a little markdown cell message here. And in my markdown message, I just put my heading of like what I'm going to call it, which I think I actually kept that title. And then I just started writing. And then I was like, okay, you write. So write a paragraph about Chris. And interestingly, what you see here is not what it told me. And in fact, I can do that because if I copy this and I click here and I click submit, then Solveit only sees what's above this message. It doesn't see what's below it, right? So this, I can basically mock exactly what would happen. So this is what actually happened. Well, it's not going to be the same every time because it's not reproducible. But it's very sloppy. It's overhyped. It's hard to overstate. Lots of M dashes. Chris didn't stop there. These aren't one thing, they're another thing. Oh, horrible, right? But like, I quite like I'm better at criticizing other people's work than writing my own. So I started there, and then I hit right square bracket, and that edits answer. So I then went through and I deleted each paragraph one at a time, and I didn't just rewrite its paragraph. It's like, what's the paragraph I want? But I just found it, for me, I liked this approach. The alternative is people will tend to be like, no, don't do it this way. Do it like they'll have a long conversation where they're trying to get the AI to write the thing they want. It's like, no, just edit the output to be the thing you want. And the other nice thing is now it's going to get better and better at understanding what I want, right? And so then I wrote the next little bit myself from scratch. And I just wanted kind of little reminders. Where are we up to? Write a bit more. And then again, have it write something, which I then replaced it all. But one really nice thing here is it's giving me quotes. And if I like the quotes, I just leave them. I don't have to go and find them. So, bit of a discussion about what could the next section be, what are some quotes there, and again, then I just wrote it myself. So I'm going to just go copy paste here. So I'm going to just do the same thing, right? And I'm going to submit here, and I'm going to see what happens. And hopefully you'll find it's better than the total slop last time. And if it is, I'll explain why. So I'm saying, please draft 2 to 3 paragraphs.
There's a question in the chat that I think relates to this of someone saying, as chats with AI tends to get longer and longer, they tend to get worse and worse. Like, how does Solveit address this, and avoid getting bogged down?
Yeah, sure. So let's just look at this. So this is a lot better, right? I would edit this less. In fact, it's nearly all quotes, which is actually what I want. It's not just hypey garbage. And okay, so why is this better than before? Language models are autoregressive. They've actually literally been trained to predict the next word of a sentence or of a document. That's a bit of an oversimplification because they're then fine-tuned. But in the end, the thing they most want to do is to give you the most likely next word of a document based on previous documents similar to this one. So if you've got lots of prose written the way you want it to write, then it's going to write more prose that looks like that. So it gets better and better. And the more you tell it, no, not like that, no, not like that, no, not like that, the more examples it has of things you don't want. And it's going to get really good at creating more crap that you don't want. So this is why you want to be editing the outputs. Even better trick I quite often use is I'll let it do garbage once. I'll tell it why it's garbage and how to fix it. I'll then ask it to do it again, and then I'll edit its output. So now it's got an example of it doing it correctly after being kind of reoriented. So, yeah, I actually don't have too much problem with context bloat. To be honest, I find doing things these ways when doing quite small amounts and it's all carefully controlled, it's basically fine. And also, like, there's no garbage in here. The only things in here is like the conversation I want, right? And the actual outputs I like, and the transcript I'm working from. If we literally run out of context, then it will start to truncate stuff from the top. Now, obviously, I don't want it to truncate the actual. I don't want it to truncate the actual transcript that we're working from, which is why I've clicked this little pin button. See how that's red? So that means, yeah, stay there in the context all the time. But yeah, I don't know. I don't find it too much of a problem. Johno, do you have much of an issue with that?
I tend to work in much shorter notebooks. I think the times I see people starting to notice it is when they have extremely long dialogues that are, moving around. And so then using you can hide certain things from context, pinning the important stuff, like those tricks tend to help. Yeah, like you, I almost never have an issue with it because I'm almost never working on, a book's worth of content. It's much more like smaller pieces.
Something else that happened here is then I kind of created a draft and I showed it to my team and I showed it to my wife, Rachel, the co-founder of Fast.ai, and got the same reaction from basically everybody, which is, Jeremy, you've kind of buried the lead, the thing you're most passionate about. you know that you care the most about, you've put too far down, and it kind of starts out too dry. And so what I actually did, here we are. I've said it. This is my feedback, right? So it's like, you know, I wanted to be more clear about my concerns, more clear about Chris's position. What are some quotes? Here are some quotes. It's like, okay, help me draft a new opening paragraph. And then I went back and I inserted that opening paragraph back at the top. So then I tell it, I've gone back and make that edit. And so I just kind of double check. Are there any points he made that we didn't mention? Any awkward transitions? And it's like, yeah, there's a bit of an awkward transition, you know. So I ask, okay, help me with it. So then it's like, yeah, it actually did a good job. So I ended up basically copying its suggested transition. And then I wanted something for YouTube, which I didn't care about too much. So I edited it only a little bit. And then a few days later, I wanted to send an email to folks about that interview I did at the PyTorch conference to our alumni. So it's kind of nice because I could add now and say like, hey, you know, I wrote an email, you know, and it had all that context of the Chris Latner thing, which is nice. So I could say like, hey, what do you think of this email? And actually the suggestion it had was a good one, which is I didn't mention Swift for TensorFlow. I went back and edited it. Probably most of you received that email. And so now I want to create another article this week from my PyTorch conference. So I actually duplicated that Chris Latner dialogue entirely. And I have added to the end of it the transcript of my PyTorch chat. And I'd like, okay, Latner piece was published. Now I want to write about this. What are the themes? And it's kind of nice because it knows what I'm doing. It's got my voice, you know, and was able to get started a little bit. Anyway, this is as far as I've got. But maybe later on I can show you all. But I think the key thing, like apart from anything else here to remember, is like I didn't start with a blank slate, you know. And so something I love doing is when I do have a blank slate, is I'll just grab somebody from my team and I'll say like, can you interview me? Like literally, I'll say, please interview me. It's like, what do you want me to interview about? And I'm like, okay, these are the ideas I have. I want to kind of get out. And so, and then I've kind of found there are certain people who are really good at that. They're genuinely interested and they kind of ask engaging questions. And I record the whole thing. I throw the interview away, but then I go through the same writing process. And I find it helps me get my voice. You know, a lot of people, when they write, they default to either like some really bland Year 12 English voice, you know, 3-part essay voice, or they go into some ridiculous, hypey salesman voice. Like, but we want to hear, how do you sound? So when you talk to a friend, you're going to sound like you. Otherwise, your friend's going to be like, Jeremy, you don't sound like that, weirdo. And so with those words, then you can just style transfer that into an article form. So that's something I found super helpful, and it's a way to use Solveit to speed things up, get much more in the flow, avoid writer's block, but not create slop. What do you think, Johno?
Yeah. It's funny how similar the overall process looks, like the advent of code and the writing is like, okay, here's some context on what I'm doing, right? We copied in the advent of code problem and we voice dictated some description. Like, okay, we started with the transcript. Here's what I want to do. Then working in small pieces, looking at the output. Is that what I wanted or not quite? Yes, it's the same flow, but the writing, yeah, it's various people asking, how do I get the transcripts? I don't know if you want to talk about that. Was the main question that came up, is like, how do we get
Oh,
that starting
sure.
point?
So there's a few good ways. We're working on a kind of transcript API, which hopefully we'll have maybe by the time people watch this recording. But actually, there's a few good ways to do it. If you use Zoom to record your interview, there's an option you can check in the box in settings to say create a separate audio file for each participant. You can then drag them into Mac Whisper, and it'll automatically generate a diarized transcript, a transcript with people's names on it. And in particular, choose the parakeet model. It's like, takes about a minute or less, maybe 30 seconds to do an hour, you know. And then often what I'll then do is I will paste that into Solveit and say, can you please fix up this transcript? It's probably got some errors because it didn't know, like in Mac Whisper, you can give it vocab items, like I gave it Fast.ai, Solveit, stuff like that, FastCore. So it, you probably noticed when I was using my voice prompts before, it all came out quite nicely. But you can always have Solveit fix errors in your transcript. Gemini is pretty good for it as well. You have to cut it up into smaller pieces. YouTube does do an automatic transcript. They're pretty crappy, and they won't have that diarized interview format. But again, you can have a AI fix it for you. In the end, you'll probably find it doesn't matter too much. You'd be surprised how garbage AIs can handle.
Nice. All right. Well, should we move on to the third and final section of
Yeah, I'm
the
excited about this.
day, Jeremy?
I've seen a preview, and it's basically putting all this together into something that's going to blow your mind, I think.
Yeah, this is a piece that I've been playing with. And actually, first of all, this is running in a Solveit container, and it builds up an application. And the goal of this is to give you a bit of a taste for some of the pieces that we'll be expanding later. So don't feel like we're trying to teach you a ton in the next half an hour. It's more like a bit of a showcase. But I'll share this link in the YouTube chat. And the idea here is that we're going to build up this kind of side-by-side arena type voting setup where we'll pit two models against each other, and then we'll pick which one we prefer. This one's kind of a tricky distinction, but I'll choose to vote for that one. And then we'll have some live votes that we can see. So feel free to open that up in a different tab while I'm going through this, and you'll see how we build that up in that same way. And so just like with Jeremy, he started with the advent of code, which already had a nice problem description. For this one, I had this idea in my head, so I don't have a nice written description, but I could write down, we're going to build this SVG arena. Two models are going to be pitted head to head. They're going to generate an image based on a prompt, and then we're going to store the results for later. And then I just started going through what are the pieces that I need to make this plan a reality, right? Because I could try and give that whole prompt to AI, but that's obviously not the way we're trying to work. So instead of thinking like, okay, what pieces do I need? And these are going to be pieces that some of them at least will come up again as we go through different demos throughout the course. So one of them is calling language models, right? I would like to ask LLMs to produce these pictures. So I need to figure out how to do that. And I thought I'd try something which I haven't used before, which is a tool called OpenRouter. Or OpenRouter, I guess, asking the language models to produce SVGs, turning this into images or figuring out how to display them. And then I'd like to create this FastHTML app that actually sets up the user interface, store the votes, show the results, making everything a little pretty. So that's me just laying out like my overall objective so that as I go through this, both me and Solveit have this context for what we're trying to build. And so I'll work through the pieces bit by bit. Number one was I'd like to call an LLM, or in this case, I'd like to pit multiple LLMs against each other. And so I went over to OpenRouter, headed to their docs, and right in the quick start, there's a piece of code that I can use. And so it was funny when I was talking with Jeremy about this, it was like, oh, okay, what was the decision function for when should you go to the docs? When should you just ask Solveit how to do something? What are the different ways you could approach that? Because you could very easily here say, okay, I'll prompt Solveit search and show me how to call a model with OpenRouter. Right, I could just as easily have asked it to use its built-in search tool or its general knowledge to go off and find that. But in this case, because this is like the primary, oh, sorry, I'm showing the wrong tab. This is the primary piece of OpenRouter's functionality is that it lets you do this. I had the intuition that that would be front and center on the docs if it was good docs, and sure enough, they were. And so either way, you end up with an example piece of code, but then we can take that and make it our own. So I listed out the models that I wanted to test, and we can maybe do some good Solveit hygiene and check that those lists indeed contain what we were hoping for. And then from that example, I just used the keyboard shortcut, Control, Shift, and then the minus or hyphen sign to split the cell into different pieces so that I can work through bit by bit and start to inspect like what are the pieces, right? And so even here for this one, this is what it tells you to do: client.chat.completions.create, specify your model and a message, and then pull the result out, right? And so if you're exploring this, you could start out by just looking at what
So
is this
Johno,
completion thing.
often I find my first reaction, and a lot of people's first reaction, is to kind of get AI to do that first bit. And I've realized it's actually almost always less good than going to the web page of, like you did, and just saying like, the way you went to the docs there is kind of like a bit retro, But actually,
Right.
I generally find that the curated first starting point provided by the company that literally, or the individual that created the piece of software, is generally better than the random thing that AI generates as its first example. So this approach of actually reading the docs is still useful even today.
Highly underrated for sure. Yeah. And like you probably think, okay, maybe that piece of code didn't feel like a giant piece of code, but still, yeah, reading the docs and then taking the pieces and just executing them bit by bit, right? Like I could inspect what is this client, or I get back this completion and I can look at it and say, oh, okay, it's a completion, it's got an ID, it's got a list of choices, they've got finish reasons. I could kind of dig through. And so then by the time it gets to like, okay, this is what we're doing, if I wanted to ask the LLM, what is the best day of the week,
While you're
whatever.
typing that, I'll just, look at this button, I can press it. There we go. So at what point do we set the libraries we need installed in the environment? Which ones are already pre-installed? So actually Solveit knows which libraries are pre-installed, so you can ask it. The answer is most things that you're likely to need are pre-installed, and it's pretty much everything that we use in the course will be pre-installed. It's fine to install something that was already installed, but by using our version, you'll be assured that you're getting the most recent version and it'll be automatically updated for you. So I would say try not installing it first, and if it says not installed, then install it.
Cool. Okay, so in the same way, I'm going to move through. This is a notebook that I've already written, so I'm not going to do too much live coding. But we're going to use some of the same practices that we've already seen of moving through my plan. I've tested out sending a message once in isolation from the example. I can now create a function to quickly wrap that up in a prompt, right? To say create an image based on this description, and I can check that that works, right? I can look at the completion. Then I can think, how might I extract the SVG path? And even sometimes using Solveit, I sometimes switch modes to concise or standard, where it's more just giving you a result straight away. But the learning mode is so good in that when you ask a question like this, it's very good at just like hinting to you like, maybe this is so obvious you should do it yourself, right? Find the first and last one. Using Python's find, sure. And so in that case, it's kind of like, okay, that's actually enough that I can do that myself, right? So I can find the first and last, find the piece that I want, the starting and ending tags. I can find the string in between, and then I can check if I can display my little whale, and I can, right? So we're doing everything in these small pieces. We're doing everything in this way that as soon as I've run something, I'm inspecting the output and seeing if it's what I expected and whether or not it's working. And then we can wrap that up into a function, right? So then I can say, here's my function now.
Let me just pause for a moment, Johno, because I feel like this is way too amazing and you just like zipped over it. I mean, it's not because we did anything impressive here that this works, but because we're leveraging the browser. Browsers are cool, and browsers can draw vector images using a whole language designed for vector images. It's very different to like something like Claude Code or whatever, where you're kind of like switching between things and setting up MCP servers to look at them. And I really encourage people to lean into the fact that your browser can play MIDI files, can play WAV files, can record, can draw pictures, can show buttons, can make sliders, and the AI can make it, the AI can look at it, the AI can comment on how you did it. This is so cool what you've done here. And like, you and I feel like, Johno, we're so used to it at this point. But there's nothing else like this, right? Because it's running on a full Linux server that we've provisioned for you. Like everybody's running their own Linux server. So, it's not just a little mini JavaScript version of something, and it's not going to disappear when you're done.
Yeah, that's a good reminder, Jeremy. This this is magic technology, right? We have this machine where we have running code, right? In this case, code that's able to execute Python. We have an AI that can see everything that we're doing, and that's super smart and able to just push together some symbols to create a fish. We have a way to share that with people and to inspect it and to view it in new tabs and to render it out. Yeah, I guess thanks for the reminder to like stop and appreciate the scenery here.
Oh, and just
Mhm.
question on the chat. In the Discord, we have all of the links to Johno's dialogue and so forth, and in the recording we'll also make sure that's in the YouTube description.
Yeah. Okay, so to play on that magic even a little further, I'm now going to show building up the interface for this in Solveit. So this is going to rely on FastHTML, which is a library that we at Outsource AI developed. And again, this isn't like, don't feel overwhelmed that this isn't a FastHTML tutorial, so I might skip over some pieces fairly quickly. What I do want you to see is that the approach we use for building this is also the same iterative small pieces thing, right? So we're creating a FastHTML application.
It's also how
And
Solveit's created, by the way. Like Solveit's created in FastHTML, Solveit's created in these kind of small steps. Like you can use this to create much, I think this is already a really cool app that you're creating, but you can use it to create full systems that teams of people spend over a year on.
yeah, and so we can create these little interactive pieces, and then this app is an application running on a port on, in this case, my machine. In the public version, it's the public URL that you can copy. And so if I go over to a new tab and I go to port 8000 and then type /hello as the URL, you can see we've got our code rendering up, in this case, some text or some HTML into the wider world. And that's exactly what's happening for the app itself. This is running live from the, I guess you call it the production version, right? My solve.it.com version of the application. And so the neat thing with this is, so you've all been playing with the app. I can interact with all the pieces of that. This list of votes are the list of votes that people have sent to the different AIs and which one got voted for and which one didn't get voted for. And this is all something that we can build up in this very incremental way, like one piece at a time, one route at a time, one small piece of user interface at a time. And so that's exactly what this dialog goes through, just a very like incremental, okay, I'd like a form that I can put as my prompt box, right? So here I've got an input to type in the prompt and a button that clicks submit. And at the moment it does nothing, right? It's just a piece of UI, but I can see, okay, that's starting to look kind of like what I'd want, right? Then I can generate some SVGs and explore like what happens if I try to show them side by side. But, in this case, I used the ghost text and it didn't do a very good job of making the kind of user interface I wanted. But that's okay. We're in this environment where Solveit can see what we can see. If you want to include a screenshot, there's a shortcut for that where you go, was it Command Shift comma, and it'll ask if I can share my screen, and then it'll include the output of the previous cell. And I can ask it, could you make a nicer version of this piece of user interface that I'm trying to build? And so, yeah, especially as you get more towards this kind of styling side of things, at least for me, it's a zone where I tend to enjoy relying on the AI a little bit, right, for some of these heavier pieces, but also that doesn't preclude then going back to the solve it, understand it yourself, do it in small pieces. Or in this case, I guess learning mode is helpfully prompting me to try it myself rather than.
So just to explain here, so where it says output included in that prompt, so what that's done is normally the AI can only see the HTML that was generated, but if you see output included, that's because Johno hit this Command Shift comma and it automatically took a screenshot of the output of the previous message. So it can see that, and it's not just now. If Johno did, do you want to try doing a follow-up, Johno, and just say, yes, please do it for me?
Sure.
it can still see the picture.
And you could also just take a screenshot yourself and paste it, right? I'll use that to put in a drawing that I've done or something like that. Okay, it's giving us a very long and complicated one. But for now, I'll show you the version that I got on concise mode. And then I'll show you what I've done is just taken that piece, tweaked it a little bit to check, okay, do I understand what's going on? We've got this big block, which for now I'm treating like a block of magical, mystical gibberish. But then we're showing a style and then a div, and it's got a heading for the model, and then it's got the SVG, and then it's got a button that says vote. Okay, and that's looking brilliant. The first round, it actually didn't look brilliant. I couldn't see the text for the vote for this, but I could ask AI, okay, this text is invisible. What should I change? And then it directed me, okay, this is the line you should look at. And so then immediately, like this first pass of having the AI do a prototype, right, or so, some like starting point, it gets you to like, okay, that's either close to or far from what I want. But then this revision to say like, oh, okay, I can change a color, right? And then you start looking and you say, oh, the button has a background color. I can set the foreground color by adding a little piece of extra. I'm not someone who loves CSS, but I can start to see how, some of these pieces play together and make sense. And if you're unsure, you can always ask, right? Like,
That's probably the best way to learn CSS is this way, is, to experiment with it and see it immediately. While you're typing that in, I'll just mention there was a question from the chat, which was about, does Solveit support working with large code bases like Cursor does? The short answer is yes. You can, we'll show all this later. You can use Git, you can clone, you can sync, you can use tools which can read and write to the code base and so forth. But also, like, it doesn't come up for me almost ever, because I've learnt to create quite nicely decoupled, fairly standalone things that work nicely as dialogues. And very little boilerplate, so everything's kind of quite small and self-contained. And so to me, if you've got a code base that requires looking at 15 different files to answer a question, that's a problem to solve. So I would start there. If you're going to have a human-centered development process, then you need to be able to easily keep the structure of your code in your head. And Johno, you'll remember a few months ago, we over-invested in agentic AI ourselves, and Solveit's code got overly complicated itself, and we lost our development velocity. And so we actually stopped creating new features, and we said, right, we're not going to create any new features until we've rewound, until we've got everything so we can keep it in our heads and that all of us feel, and remember we said, like, okay, don't pretend, don't lie, like, tell us, everybody, are you now comfortable fully working in this environment? And until everybody was like, yes, I can work in this environment, we kind of put things on pause for a few months, didn't we?
Yeah. Yeah, and I think it's a lot harder to, tell that to somebody who's maybe just one part of a larger organization or working with existing teams. So I will say there's degrees to which you can embrace or aim for this.
That's
I
true.
think at
Yes.
Answer AI, for sure, there's the ideal and then there's the like practicality. And as long as you're
Absolutely.
aiming for that direction to say, are there ways that today I can make this a little bit more understandable, a little bit less verbose?
But I
Are there
know in
ways that
our
I can?
audience, for example, we have some software directors and CTOs of really large companies. So this is to them also. It's
Right.
like, embrace the software engineering goal, which is that everybody in your company feels capable of understanding and modifying what's there, and maybe to folks who are earlier in their careers to speak up if things are too complicated to follow or are getting more complicated, because it seems like it could be a potential road to extinction for a company heading too far that way.
Yeah, for sure. All right. Well, I will just to finish showing up the pieces here of this little example. I'm trying to think how best to frame this. Yeah, it's all the same thing, I guess, is the takeaway, right? I'd like to experiment with once I submit something in the form, having some response come back. So I can make a form that uses HTMX, which is something we'll talk about when we get to web apps, to send a prompt off to a new route, which then returns some new UI. Then we can iterate on exactly how we're doing this side-by-side display, right? It's okay, that's looking nice. Now it's all hooked up so that it also uses this interactivity to send off to a new route. But like even here, I don't know, Jeremy, you're probably looking at this. Like this feels like the upper bound on how much I'm comfortable doing at a time. And the only reason I'm comfortable with this is because this is a modification of a version of that piece that I'd already done. This is a modification of a version of that function that I've already written. And it still feels like if this was more than a one-off demo for this lesson, I would probably come back and figure out ways to tidy this up even
If you
further.
scroll up a bit, just back to where you were, I mean,
Mhm.
yeah.
This
I
guy
mean,
here.
apart from
Yeah.
anything else, it'd be like, I'd feel reasonably comfortable with this because it's very obviously duplicate code that we can very easily remove, like because we've got two buttons doing basically the same thing. And I'm very much of the view of like, this idea of DIY, don't repeat yourself, can be definitely taken too far. I would say, like, when you're playing around, just repeat yourself.
Yeah.
JRY, just repeat yourself. And at the point that you're repeating yourself, then it's like, okay, factor it out, put it in a function. But this is, I think, very easy to keep in my head. If I found I had a bug more than once that I forgot to add some attribute, and now I've forgotten to put it in both the two places, and again, I'd be like, okay, pop it in a function. It's also the kind of thing that Solveit's very good at doing for you. Is just like say, hey, can you refactor those buttons out into a function? Little stuff like that. I try to keep my limited intellectual capacity to where it's useful. So for something like this, yeah, I wouldn't mind it, And if it doesn't do it perfectly first time, then I just go and do it myself. But I bet that would work. And we haven't told people, you could now hit W, Johno. Do you want to tell people
Oh,
about
right.
W?
Yeah, there we go. There's the piece. Okay, and then we want yeah, it'll use that pair.
So do you want to talk about W?
Okay, yeah, right. So W is a shortcut that would take any code blocks from the AI output and immediately add them as a new code message. So that was how I was able to very quickly ask for, in this case, a refactor or a new piece of code, and then just hit W to get it, and then Shift Enter to run. So if you are asking for snippets or could you give me an example SVG I can use with this, whatever, like small pieces of code you're requesting from the AI, it's a very quick way to get into it and start editing. And then you can always come in and edit further and say, oh, I'd like to, clean this up somehow, or change what order things go, whatever like modifications you want to do, you can go back in and do them.
Quick question here. Just I think that a common misunderstanding here is when we're saying keeping things decoupled and reasonably architecturally clear, that doesn't mean we do everything in a single dialogue. So Solveit's not a single dialogue. I think it's 9 now. And we will be teaching you during the course how to structure these things. But like I think most pieces of software of Solveit's complexity would be many hundreds of files, if not thousands. So 9 is not bad.
Yeah. Yeah, we have the export functionality that we'll show in future lessons for packaging up just say the core functionality separate to the exploration into a piece that I could reuse. But you'd be surprised how far, like Discord Buddy is an example that some of you have interacted with already, right? Discord Buddy is a chatbot in our Discord. You can ask it questions. That entire application is written in a dialogue by our colleague Eric. And you can go in and explore. You can see his thought process all the way from like learning the Discord API and interacting with LLMs to like bring all the context together to the full running app is there in the dialogue. And any of us can then go in while it's all live, while it's running, add extra routes, investigate the database, add some new knowledge to the repository that it's drawing from, test something out. So you'd be surprised how far this kind of like dialogue as an artifact scales. And you might have noticed while I was showing mine, I just have the sections collapsed that I'm not working on at that moment. So you can always like organize things by headers. You can.
And to be clear,
Mhm.
so the question here about can you show the keys we're pressing, we'll show keys in future lessons, but like for this one, we're not trying to provide a documentation of how to use Solveit. We're trying to describe the ideas. And as we get further into the lessons, we'll be driving further and further into the details, including what buttons to press.
It's a good like if you see some particular action, like how did he expand that collapse section? What was the keyboard shortcut? Dump that in the chat, and whichever of us is not speaking can either answer there, or I can say, hey, just by the way, I'm using left and right arrows to expand or collapse the
And there's
different
also
markdown
a
sections.
button. There's a button in Solveit you can click that'll show all the keyboard shortcuts. And we
Yeah,
added them all
yeah.
for a reason, so they're worth learning.
Yeah, no. So, but if you see something magic, ask. But we'll also, this is lesson one. Hopefully, like the tasting, amuse bush of the menu, and then over the next 5 weeks, we're going to be expanding some of these examples, spending a lot more time working together, pairing on everything from more advent of code to the pieces.
Yeah, and
So
again,
you'll see all these patterns.
as I mentioned at the very start, it's like this question about like, hey, how do you take this and what do you do? Like, we're going to get to all that. Like, okay, so it can all be fully automated. We've got lots of systems in place. Don't worry about it. Okay. For now, bit of copying and pasting, or go and Google NBDev. It's all integrated into Solveit. But yeah, we'll all these details we're going to get to. But at the moment, we really want to focus on the techniques that hopefully you can start to use in whatever software you're using.
Fantastic. All right.
So
Jeremy,
can
were
we
there other?
see? Well, I want to see
Mhm. Oh, right.
you know, what you
The
got.
the final piece. Okay. Let's see. Was there much more that we hadn't covered? Um, oh, right. Okay. So we creating a list of votes and a route that takes the winner and loser and prompt and stores the vote. I think in the final section here, just marginally before the lesson went live, I quickly asked the AI to help me, add a title and some styling, tweak the vote route to show, you know, things like how many winners and losers were there. And all of this is stuff that I would really recommend, like if you were actually going to use a piece of code like this, and you've now had the AI give you some larger chunk, but this isn't a piece that I built up piece by piece, split this back out, which I was maybe going to do if we had a lot more time, and look at the sorted models list, and then look at the tally display, and then look at the group together. But this is pretty much all there was to it, other than a few like styling
So,
tweaks. Right, yeah, so that's this application here. So I could type in, I don't know, a dog, see what the is do.
and just to be clear, it's not that you exported this or deployed it or anything. Like anything that's running inside your dialogue is also a running app that other people
Right.
can use. You just click the share public URL button, and it's kind of really nifty because if Johno, do you want to try it? Johno, change a message and run it. Yeah, this is cool, and you can see the votes appearing right in the app. And if Johno changes one of his messages and runs it, which defines a route, he
Yeah,
doesn't
so
have to
let's
redo
change the
anything.
name of this. Let's rebrand this to Drawbot Arena, right? So I'm overwriting the index route. So if I go back to the app and I load it, the live app has changed. Everyone, if you visit that public URL, which is the URL of my instance,
And
you
there's nothing in
see,
the background like regenerate, like because there's no build step here. It's like literally running from the running Python interpreter. It's a really kind of unique way. Well, not unique. It goes back to how Lisp and Smalltalk used to work, but it's something that has been slightly lost to time. But it's such a cool way of running apps live and modifying them as you go, and like literally the code's appearing, the results are appearing here in Johno's dialogue in real time.
yeah, and we can watch as new ones roll in. Um, yeah, so I don't know. I think this is a somewhat silly example of the category, but this idea of being able to build up dynamic web applications, be able to add functionality on the fly without the app even having to restart, be able to share the source code in a way that someone can make their own version and then deploy it on a public URL without having to worry about setting up and configuring. Yeah, it's a ton of fun. It's a really enjoyable way to work. And
And
I
so
hope
then,
we see, yeah.
yeah, that's great. And so Christopher is asking how long the live URL lives for. It lives as long as you run it. So if you click in the top left on the Solveit button, it closes your dialog. So if you don't click it, it just keeps running forever. And you can create multiple instances, each running their own app. And we don't actually have any real scores yet, do we, Johno? Do we need to provide this to the community so that they can all decide which model is best?
Yeah, let's see. Okay, so I restarted just before the thing. I think it shows the tallies, the current rankings. GLM 4.6 is 4 votes, Gemini 2.5 is 4, Minimax M2 is only featured in 1 or 2. We'd have to, I think, get a lot more people voting
All
to
right.
average those out.
So
But in
let's
general,
get the students coming up.
all right, I'll leave my public instance. I'll have to start a new one for a new application so that this can run for a bit and collect some data.
Great. So yeah, so where to from here? It's hard, right? Because I've kind of been living in this exploratory programming world for nearly 10 years now. And actually, in some ways, ever since I first started using Mathematica like 30 years ago, this is my thing I've always wanted, is to be able to like craft my code, like I'm molding it and chipping away in it and seeing it happen in front of me. And for anybody following Brett Victor's work, it's very similar to this idea that you're watching what you create and it's right in front of you. But it's so different to the normal IDE, agent, multi-file, build step, whatever. Well, so that's okay, but hopefully at least it's giving this idea of like, can you make your steps a bit smaller? Can you make your iterations a bit faster? Can you make the feedback you're getting a bit, more direct? So that you're not going to have weird bugs. Like, I never need a debugger. Like, I'm pretty good at using a debugger. I think they're a very clever piece of technology, but why would I need one? Because if I have an error, it's because the last 2 lines of code I wrote had a problem. I can immediately see it.
Mhm.
So hopefully, I think it's just like, can you bring a little bit of this style into your work, and maybe can you practice it in the Solveit platform with something, maybe you could try to build a little PyPy module or solve an interesting advent of code thing. Or, it would be great. Is there a video out there that you love? And wouldn't it be cool if for that person you created a marvelous article version? Like, is there a Fast.ai lesson that you think is great, or is there a Lex Friedman interview that you find fascinating? Anything like that is going to be amazing and an opportunity to practice these ideas.
And as far as concrete homework goes, I think the other thing that I want to mention when we're encouraging that is that it takes a little while to get into, right? So share your results, but also especially these first couple of weeks, if you're trying it and finding like, oh, your natural instinct is to go back to writing 4 lines, line to split, then this, 4 or 5 steps at a time. It really does require some deliberate practice to unlearn the habits and to learn the new pieces. Hopefully I see someone commenting it looks daunting. Yeah, hopefully you try it and find that the more you start to practice this approach, the more effortless and natural it feels, but that does take a while. There's a big hump to get over. And so I'd really encourage all of you to go actually try and put these into practice, load up an advent of code or two. Yeah, just really attempt to get your hands dirty with this approach because it's something worth practicing, I think.
Thank you, Johno, and thank you everybody for staying with us. Thus ends lesson 1. I hope you got something out of it. I had fun, and see you next
in the
time.
Discord.
Bye.
Cheers, everybody.